Okay, a couple weeks ago, I made a video about teaching my 6-year-old multiplication. And we walked through how multiplication is repeated addition, and they added it up and they got the 64, right? Immediately after I made that, I wanted to make this video, which is a little bit more general, building on that same topic a little bit, but has a much broader impact on how we talk about math. So math is extremely literal, okay? So I'm going to give you the base case version of what I'm talking about. We talked about 8 times 8, and that is 8 squared. And back in probably elementary school era, you may have gotten to play with these little cubes to represent multiplication. I know I did. And so if you take 8 of them, and you take 8 of them in the other dimension, right? So you have, and then you fill that out, you make a square. And the value of the number of little cubes that it takes to build that square is 8 squared, right? Same thing if you extend that to 3 dimensions and you build 8, 8, and 8, you build an 8 by 8 by 8 cube. And the number of little cubes that we would use to build that was 8 cubed. The concept extends directly from the word usage inherent in how we describe it in the first place. Now, I'm going to get a little bit nerdier about it because as a mathematician, I've gotten really nerdy about word parts because I realized that all the things that we define, the word parts tell you exactly what we are doing. Even the word multiplication or multiply, multi means many, and the plication or ply has to do with folds. And so in a sense, I recognize that you may not see addition as folds, but if I have 8 on 8 on 8 on 8, right, 8 times, that is the multiplication of 8 and 8. So 8 folded 8 times, in a sense. Multiplication by the word is many folds, right? It's an action of taking many folds. If you multiply 2 numbers together, then you are taking many folds where the first number, even if it's 2 and 3, which I think I talked about in that last one, right? I'm taking effectively 2 folds of 3, you could think, right? And if I have 3 and 3, now I have 6, and 2 times 3 is 6. So multiplication, and then just to give you, I guess, like a snapshot of a higher level concept where this also comes up, the one that stands out the most to me from this semester is in my differential equations class when we were talking about bifurcations. Again, this is an action effectively where it's by, to, fork. So you end up with an action that causes a forking in the number of solution cases. That is what a bifurcation is. You don't need to understand differential equations to understand that bifurcation means that you split into 2 forks when a bifurcation happens. And the reason that I want to talk about this is because one of the biggest hurdles for a lot of students is they're like, I don't even know what's being asked of me here, right? They don't know where to start or what's being asked of them to do computationally because they haven't made the connection necessarily between the word parts and the math. And oftentimes they're struggling with the math side, the computational side, or memorization of it. And the word tells you what to do. So I try to stress this in pretty much any math class that I'm teaching. It doesn't matter what you're doing, whether you're doing arithmetic, algebra, calculus, beyond, any of it. The words that we use to describe what we're doing tell you what we're doing. So if your weakness is the math side, the actual computational side, then you can spend more time emphasizing what the word parts mean to figure out what you're supposed to be doing mathematically. That's my hopeful takeaway for you. Math is extremely literal. If you understand the words, then you can understand the concept, and from the concept, the calculations will unfold.